Hello, class. I'm here to continue talk about chapter 4. If you have not watched the videos that I uploaded about PDF or probably probability density functions, or if you not have watched the combinational or combinatorial formula video and factorial, please do it so, which is going to make it easier for you to understand all these calculations. Chapter 4, it's all about discrete random variables and its distributions. And chapter 5 is going to cover continuous random variables. Under chapter 4, we have hypergeometric, binomial, geometric, and Poisson distribution. When I was thinking about chapter 4 and how we only have an accelerated 8 weeks program, I don't find realistic that you remember all these formulas or understand each one of them, how they're calculated, or remember all the definitions of the distributions. So the way I decided to do it is to actually put on an Excel file each distribution. Okay, in this case, we're going to have first the video for the hypergeometric. Why am I using Excel? Because Excel actually has formulas for us that will make this so much easier. So when you're able to determine the values, to sort the values, all you have to do is to go in here and plug on the formula that I'm going to show you, and then you get the answer. And I'm going to prove that to you. Things that so basically the hypergeometric distribution is going to be a discrete probability distribution that is going to describe the probability of success in a draw or in draws without replacement. Okay, so what does that mean? Which you're gonna see on your book and probably gonna wonder. You should see it here. Here we go. Another way to say that this is your simple without replacement, and therefore each pick is not independent or dependent. What does that even mean? Let's suppose that you have five cards, poker hand. Okay, and then you're right here. The five, here we go, five card poker hand. And then you're doing a trial, right? And you're trying to define something. So without replacement means that when you try it again for a next experiment, now you have five cards poker hand. And then if you remove that card, now you have three cards, and then you have two cards, and then you have one card, correct? That what it means without replacement. That means we don't put that card back on your hand, which that's why it's called it depends. It depends if you put it back or not. So in this case, they are dependent. You must remove. You cannot replace. You cannot put it back on your hand. Okay. So just the from the book, you have to have two independent subsets. They see one aces, one no aces, or a true and a false, or let's say a runner and a non-runner, or so the opposites. That's what they mean by two independent subsets as well. And see, they must have changing probabilities because you do this modification right here without replacement, and therefore each one is not independent or dependent, each pick. And lastly, the variable must be discrete rather than continuous. So you're talking about one card of aces. You cannot have half of a card. You cannot have one third of a card. You have one, two, three. So that's what they mean by discrete. So right here, the formulas, what does this mean? I took this from your book. Right here, they tell you that this whole formula over here is supposed to be 0.0399, right? So remember, we're talking about two, you wanted two aces, right? Right here, from a four, from the four in the deck, two aces out of the four possible ones, right? And then they're saying, and then you have the other hand with the remaining. So if you have five card poker hand, so you took two, now you have three. So that's three over here. And then if you had 52 and you took four cards, now you have 48, correct? And this is the total, 52 cards in a deck and 5 in your hand. So those are the values. So let's go over here. So you're looking for two cards and in a total of 5 on your hand. A or K in this case over here is gonna be 4 because there are 4 aces total, and the total population or the total amount you have in a deck of cards is 52. So I'm just translating all these numbers over here from this problem and plugging into this formula right here. So once you're able to define this, all you have to do is look at this formulas. What does it mean by false and what does it mean by true? False means you do not want a cumulative value. That means you want to X exactly 2 cards, X exactly 4 cards, X exactly 10 cards. When you do the true, you're doing a cumulative value, which means you want to know from um, at most X success. So if I tell you at most uh, 4, let's say 4, then you will have to calculate 1, 2, and 3. So you're gonna have the cumulative values for those picks. Okay, so we know that we just wanna X exactly equals 2. So let's try that formula. Let me copy this formula down here, and then I'm gonna get rid of the text. You can read that. So which is just reading probability of X axis in an amount of trials in a population with K or A successes, in this case aces, in n elements, in a total of n elements. That's what it means. You know, for Excel to work, you gotta put an equal sign in front. Okay, so now it's gonna give you an error because I didn't put the values. So let's substitute. So let's look at over here. Okay, so X is 2, N is 5. My K, which is I have 4 aces, right? Heart, clubs, diamond, and spades. So that's 4 in a total possible 52, and I don't want it to accumulate. I don't want it to be a cumulative number. I want exactly 2. What is my probability? It's going to be 0.399. Let's see if we are correct. So the answer on your book, here we go, is, make it bigger for you over here, right here. 0.0399, and we are correct. So instead of having to do all these calculations and learn all these formulas, all I did it was to use these formulas. If you have a problem, if you would modify and say you want a probability of at least or at most, then if it was at least, you would do 1 minus the probability of at most, and if it was at most, then you have to use true to do the cumulative. But if it tells you that at most 4, so you do just 1, 2, 3 values, not 4, because at most 4, so you don't include 4. And I'm not assigning any hypergeometric problems. I just wanted you to look at this information on the book and try to go here then and just see, like, if anything, if I would put this on your midterm for the hypergeometric, would be what are the key points for a hypergeometric distribution. Main thing is going to remember that a hypergeometric distribution is basically like a binomial distribution, like true or false. But see, on a binomial distribution, you're gonna see the wording with replacement. With the hyper right here, see, think of this drawing with replacement, and then the trials are independent. On the hypergeometric, you're gonna have without replacement right here, and they're not independent or they're dependent. And that would be the difference between these two distributions. And I'm going to do the other video own binomial, and then I'm going to do a geometric, which is basically what they call a negative binomial. And then we're going to do the Poisson distribution. And then if you ask yourself, how is Poisson, which is related to time, discrete and not continuous? Because we are trying to determine the number of events occurring in a fixed interval of time. We're not trying to determine the time. So that's why it's considered a discrete and not continuous. So let me go ahead and stop this video so we can go to the other video. Thank you.